In this video, I'd like to continue the new series of a math question each day. And for today, January 15th, 2023, we will talk about converting this decimal to a fraction. And with these question of the day problems, I encourage you to think of these as a sort of warm up. You can use these to warm up your brain for something maybe a little bit more complicated. And some of these questions will be very difficult. Some of them will be on the slightly easier side. It just depends on what I feel like presenting for that day. But for this problem, we can approach this using the tools of Algebra 1 and pre-algebra. So we don't need any more information or any more knowledge than those subjects. So if you are in high school, you should be able to answer a question like this. And at this point, I encourage you pause the video, try to answer this question yourself, and then if you get stuck or if you want to see the solution, then go ahead and watch the rest of the video. But it is important to actually try this yourself and struggle through this for at least a couple minutes, even if you don't know where to go, just so that you can maximize the learning process. The more work you put into this before seeing the solution, the better you will remember the solution when you actually see it. So at this point, go ahead and pause the video and see if you can solve this. Now, assuming that you gave this an attempt, we can start solving this. And the key thing to notice with this problem is that a set of 4 digits repeats infinitely many times. So this decimal can actually be written as 0.3854 with a bar over it. And converting these repeating decimals to fractions can be a little bit tricky, but there's a nice trick we can use. We can set this equal to some variable. Let's say that variable is a. And with this trick, we want to multiply a, or this decimal, by powers of 10. In fact, we want to multiply by 10 for each of these digits here. And we have 4 digits, so we're going to multiply by 10 4 different times. So if we take this number, let me just rewrite it, 3854, this will repeat, and we're going to multiply by 10 4 different times. We'll do that on both sides. And 10 to the 4th is just a 1 followed by 4 zeros, which is 10,000. So we have 10,000A. And what you'll notice is that by multiplying this by 10 4 times, we will move this decimal 4 places over. So the whole point of this is to move the decimal so that the repeating block of digits becomes a whole number. Or in other words, when we do this, we will now have 3854, and then of course this is going to repeat infinitely many times. We would have 3854 repeating after that, but this is equal to 10,000 A, 10,000 times the original number. And at this point, we will take this new number and subtract the original number. So let me make a little bit of room for that. And we can take this 10,000A and subtract A from that, and we will get 9,999A. But if we look at the decimals, we have this 3854.3854, and that's repeating. And we're subtracting 0.3854, again repeating. Now notice that this block of digits that's repeating will always cancel itself out. Since if we, let's say, wrote this again, we can extend this bar for each of these. Every time we carry out the subtraction, 4 minus 4, 5 minus 5, 8 minus 8, 3 minus 3, all of those will result in 0. And that would carry on as these repeat. They will always cancel each other out. That is, in essence, the reason why we carry out this trick here, so that we can cancel out these repeating decimals. And we can just focus now on this part. We have 3854, and we're subtracting 0 from that. So this product, or excuse me, this difference here, this subtraction, would be 3,854. We essentially just subtracted off the decimal portion of this so that now we only have the whole number. And at this point, we can solve for a. We can divide each side by 9,999 so that a is 3,854 divided by 9,999. And we could try to simplify this. We can see if we can reduce this fraction at all, but when you break both of these numbers down into their prime products, you will see that they have no prime factors in common, so this actually can't be simplified. And the way to check this is fairly simple. Just plug this number into a calculator, and hopefully you will get back that starting number of a, this 0.3854, repeating forever. And the other way to check that, which is much more tedious without using a calculator, is to actually carry out the long division, which will be a bit difficult, but it can be done. And in both cases, you will see that this is in fact the correct answer.